Good day, sir. I am Lawrence Mariel Rodriguez and I am here to demonstrate my midterm laboratory exam for ECP110. So we will need to simulate the following using Proteus. Create a 3 to 10 minute video to simulate your answer. So for the number 1, create a circuit and ASM program to toggle every 500 milliseconds all the bits of port B and port C continuously using 0 times AA and 0 times 55. Then write a comment and delay calculation. So for the number 1, I have my code ready. So inserting this in AVR Studio, so running it. Then here we will load R16 with dollar sign, EA, and auto port B and port C. Then we will call the time delay. Then next we will load R16 with dollar sign 55, then auto port B and port C, then call the time delay again. Then jump again to run the program continuously. So here the crystal frequency is not given, therefore I let my crystal frequency with 2 million hertz, or getting it will be 0.5 microsecond. That will be inputted in the time delay formula here. Then the value of R19, R18, R17 is 170, 195, and 10. Inserting this in our formula, we will get 170, 195, and 10. We will get 1,380,000, multiplying it by 0.5. We will get 0.500,190, 500,190, or 501 milliseconds. So running it. Then going to our Proteus, this arrange the crystal frequency to 2 million hertz. Then insert the program of the AVR Studio, which is the lab and the hex file. So running this. So as you can see, the LED changes every 0.5 milliseconds. So next, for the number 2, create a circuit and ASM program to toggle every 300 milliseconds all the bits of port B and port C continuously using COM instruction. Then for the number 2, almost the same as the number 1, but the time of change will be 300 milliseconds, and we will use the COM instruction. So here we will load the R98 with $AE, then COM. Then we will complement R19 with $55. Then auto port B, auto port C. Then repeat the process. Then we will call the time delay. Then jump again for the program to continuously work. So for the time delay, we will have the value of R22, R21, R20 with 250, 80, and 10. So inserting this in our formula, we will get 250, 80, and 10. We will get 602,430. So multiplying it by 0.5, we will get, multiplying it by 0.5, which is our crystal frequency, we will get 301 milliseconds. So running it, then we will run this in Proteus. As you can see, the LED changes a bit faster with 300 milliseconds. So next, for the number 3, create a circuit and ASM program to toggle only the bit 2 of port B and the bit 5 of port B every 100 milliseconds, then without disturbing the rest of the bits. So for the number 3, we will use the SBI to set the bit 2 of port B, then the bit 5 of port B, then call time delay. Then CBI to clear the bit 2 of port B, CBI port B5 to clear the bit 5 port B, then call the time delay, then jump again. So here we will use 2 million hertz again as our crystal frequency, and having the value of R23, R22, R21 with 166 and 10. Inserting this in our formula. So we will get 200,010. So multiplying it by 0.5, we will get 100,005 or 100 ms. So running it, then running it here in Proteus. So here when you run your AVR file, it will automatically load the current program you inserted in the AVR Studio. So as you can see, only the bit 2 and bit 5 of the port B changes every 1 milliseconds. 100 milliseconds rather. So for the number 4, create a circuit and ASM program to toggle every 100 milliseconds or 1 second of the bit 0 of port A and bit 7 of port A continuously without changing the rest of the bits. So for the number 4, almost the same as the number 3, but it only changes the bit 0 of port A, bit 7, and bit 7 of port A with the time change of 1000 milliseconds or 1 second. So inserting the value of our registers 253, 175, and 15 to our formula with 2 million hertz crystal frequency, we will get 250, 253, 175, and 15. We will get 2,295,000, and multiplying it by 0.5, we will get the 1,147.5 seconds or 1000 milliseconds. So running this program, and going back to our Proteus, it will load the current code in our AVR. As you can see, only the bit 0 and bit 7 of the port A changes every 1 second or 1000 milliseconds. So last but not the least, create a circuit and ASM program to toggle alternately every 250 milliseconds of the bit 2 of port B and bit 5 of port B continuously without disturbing the rest of the bits. So for the number 5, so we will set the bit 2 port B, then call time delay, then set the bit 5 of port B, then call time delay again. We use SBI and call time delay differently or not combining them to make it alternative. Then we will carry it using CBI port B and CBI port B. So with the value of our registers R18, R17, R16 of 238, 70, and 10 with crystal frequency of 2 million hertz or 0.5 microseconds, and inserting this to our formula. $70 and 10. We will get 1,930. Then multiplying it by 0.5, we will get 250,965 seconds or 250 milliseconds. So running this program, then it will automatically load the code, the current code in AVR Studio in the Proteus. So here it changes every 250 milliseconds. The bit 2 and bit 5 are of port B. So that ends my demonstration for the midterm laboratory exam. Again, I am Lawrence Marel Rodriguez, and thank you, sir, for watching.